So at the time of making this video, my YouTube channel's mostly been about multi-rotors, custom mini quads that I've designed and made, stuff like that. But I actually haven't touched my multi-rotors in a couple of years now. I might pick up the hobby again sometime in the future, but for now they're actually all in storage. I've been working on lots of other projects though, and I want to start posting videos about them. Firstly about my BB8 that I 3D printed and the drive system that I designed to go with it. The first step was building a 3D printer big enough to print all of the parts. When I was choosing the parts for my 3D printer, I wanted it to be low cost, but at the same time pretty high quality, and it turned out really well. The 3D files for the cosmetic side of my BB8 were created by various members of the BB8 Builders Club. The files for the main bowl that I've used are called the Vonjet 3, and the head files that I used are called the Alex and Paul Dome. For the rest of this video, I'm just going to play the last video that I made for the BB8 Builders Club Facebook page, which is about the custom drive system that I made. If you want to know more, or if you want to build your own, then you should consider joining the BB8 Builders forum and Facebook page. There are a lot of community members who've released files and designs for download for free. So I'm just about to put my drive system back into the bowl, and I figured I'd do a rundown from kind of the bottom up and just kind of explain a little bit about everything, because I don't think I'll have it out of the bowl anytime soon again, because since I've discovered these Vesks, I've decided I want to try and get my e-bike going again. So I reckon I'll put this back together with the current hardware and get it all tuned up as good as I can, and that will be it for a little while. So basically, starting at the bottom, we've got this 3D printed base, and this is filled with lead sinkers, and there's just like epoxy resin to keep them all in there. And so that screws onto this part with heat inserts, so the threads won't get stripped out, because often I will just run the screws straight into the PLA, but these are better if you're taking it apart all the time. And we've got a bunch of 18650 batteries here. I've mostly got this many because they're not super high quality batteries, so just want to share the load out, because I mean I can maybe pull 1 or 2 amps from each one. So yeah, and I've used battery holders here. Again, if I'm only pulling like 1 or 2 amps, then it should be fine through those thin wires, because they all kind of gather together. I guess if I was going to do this again, I'd probably use like Samsung 25Rs, like something higher quality, and I'd probably try and spot weld them. So then I've got these 2 sections here, which are also epoxy and lead sinkers, just for some extra weight. Originally I didn't have these here, and I kind of had provision for screwing some extra batteries, but I didn't use the batteries, and then I had the space, and then I realized it's going to work better if I have extra weight. So yeah, added that in. So those wires come through to here, and then we've got a balance lead so I can charge it, and we've got XT60. This here is a 5-volt regulator. I think it's like 10 amps. It's like a pretty beefy one. It's overkill, but it doesn't matter, because hey, it's extra weight in the bottom anyway. This board here is like a breakout board, which I was using servo connectors into. I've only got one servo connector currently. It goes to this servo, which is the roll mechanism, which I might explain a bit better once I've got that part connected. So this breakout board, don't really need it anymore, because originally I was bringing all the servos from that top section down and plugging them in here, but now I've actually got this, which is like a RJ45 connector, and then there's a single RJ45 connector, Ethernet cable type thing that goes to the top section, so all the signal and power can get to the top section that way. So basically that means like when I'm assembling the drive system into the bowl, I've just got a couple of connectors. I've got that one, I've got 5 volts from that regulator, and I've got the XT60, which is 3S lithium, up to the power switch and etc. So I think that's about it for this kind of base. I did use heat inserts for these because these screws will be coming in and out a fair bit, because when I disassemble the drive system, I leave this one on, but I take this one off. Yeah, and you can see I've got 2 ball bearings there, so I might actually move along to the top section now. So the Ethernet cable here goes up to this breakout board here, and basically this is purely just for wiring, so I can kind of join all the wires. So we've got like wires that come down here to the IMU, which is just a Joe's Drive IMU setup. Then we've got wires that go to the stepper motor driver board there, which goes to this, which turns the head, which is just continuous rotation at the moment. There's no sensor or anything to tell which way is forward, so I just kind of work it out as I go. So I've got the power switch, which XT60 comes up to, and then power kind of goes along to, well, this is powered directly from 3S. 3S goes through the slip ring to the lights, and then there's 3S to the VESC. So yeah, it's a VESC there, and it's censored, so the motor runs really smooth now. The 5045 200 kV brushless motor with the gear reductions, which I've done other videos about. So that's pretty nice. We've got the servo here, which connects to a gear. I think that belt's like a T5 belt. So this is 3D printed, obviously, and that kind of goes around there to this. Actually just put a bit of super glue there, because I wasn't really sure how I was going to join the belt, and yeah, so this belt is super glued to the gear, but that doesn't matter because it only needs to tilt that far. Totally fine. What else? That's probably most of the technical stuff for the top part. I might just temporarily put this on here and kind of show you how that looks. Okay, so here it is, kind of just sitting here, pretty much assembled. So basically this plugs into there, then we've got the XT60 into there, and XT30 to there. So basically there's like power up for the XT60, power down for the XT30. And here you can see how the tilt works with that servo. And then I've got nuts which I can put there, but in testing I haven't been doing it, and I don't think it's going to fall apart, so I'm not sure if I'll bother. Yeah. So I might actually put this in the bowl now, and we'll get it rolling. Something else I forgot to mention is I'm using this transmitter, which is a Jumper T8 SG, but basically it's an FR Sky capable transmitter, because I've got this FR Sky XM Plus, which is running S-Bus to an inverter to the Arduino Mega. And there's a library I found which works flawlessly from what I can tell. No problems at all, like no blocking kind of code. And yeah, I can read all the channels very quickly. So I designed this system so I can fit it all through the Von Jet hole in the frame. So that's the first step. The second step is putting this in. I've taken off the head rotation section, and that allows me to fit this all through the hole. So I'll do that now. And here's the drive system all assembled in the frame. So it's hard to film like while I was actually putting it in, so I kind of just did it without filming. But basically I start by putting these axle hubs in. Basically you push them as far out as they'll go and just put that bolt through, and at that point this little lip kind of holds them in place. And then I put those bolts in. I actually only got like 3 on each side. I don't think it needs as many as are actually in the frame, because this seems strong enough. And yeah, then I just put this on. Obviously the other one on the other side was already attached, but I just slide this one on and then screw those down there. And yeah, then screw this piece back on, and we're all together. Obviously connect the RJ45 and those 2 connectors, which is much easier just having that single RJ45, because before I'd have to mess around with individual servo connectors back over there. It was just a massive pain, but this is so good. So I guess we'll power it on and roll it around for a bit. One thing I didn't mention before is the lights in the bowl are powered by this Arduino Nano, which just gets power through the slip ring, and that also has a voltage divider. So when I actually turn the bowl on, I get, hang on, this is going to work better if I turn the light off. You can't tell, but that's actually like a kind of greeny yellow color. Now it goes back to blue. So basically I just get like a status indication of state of charge of the batteries, and that's like infinitely variable, not infinitely, but you know, like it's not just like set like red, yellow, green. It's like it'll like depending on the battery voltage, it'll kind of transition from green to red, and here you get orange and yellow kind of colors in between, which is pretty cool.